place, we should get out our moly lube here, lubricate the head end of the cam follower. While we're at it, we can put a little bit of moly lube here, trying not to get on the case half. This is the cam bore area. Don't put too much there, just some. Go over to either case and put moly lube on the cam follower heads. Like so, a little bit in the cam, not terribly much. Put a little bit on the main bearing, middle main. Again, don't overdo it. Moderation in these things. Take your secret sauce next and go over every place you put the moly lube on with the secret sauce. And the mixture of the surface lubricant from the moly lube and the secret sauce will maintain lubrication on this engine basically indefinitely. You can store the engine, like I say, for a long time, years if necessary. Try not to get the moly lube down the oil holes. It can dry out and cause plugging of the hole. And don't use the white grease. The white grease is available for a lot of other overhauls. I don't like to use in Porsches. I've seen, there's one case of a guy who, believing in the theory that some is better, that some is good, more is better, and too much is just enough, added so much white grease to his engine that he had white grease plugging the oil passageways in the engine. No oil pressure to the engine, and of course his engine seized because of that, all because of too much white grease. Now, that's really kind of overdoing it. It's been known to happen though, so be careful when you do. If you do get too much on the case, just take a paper towel or rag and clean off the excess oil, etc., especially around the cam plug area. Okay, and now we're pretty much ready to put the crank into the case and assemble the case. For that, we'll need the engine stand again. So now's the time to take a break, go out and get a beer, and join us in a few minutes. We're ready to assemble the case here. We have to have something to hold the cam followers from falling out. As you saw, they are kind of slippery in there. You can make something as simple as a piece of coat hanger bent in a U shape like so, which you take and stick one end into one cam follower hole and the other into the other. You have them under a little bit of spring tension. When you do this, they will stay inside. Make sure they're clean, of course, like so. This one's not quite as nicely made as the other one, but it will function. If I get my head in here to see, put one in, put the other one in like so. That'll hold the cam followers. When you turn the case upside down, cam followers don't fall out. Oil might, but cam followers won't. Now, next step is to coat the case with sealing material. I personally like the Ford water pump seal. Unlike some other sealers, which could be named, but we won't, it does not get hard. Some of the other sealers, when they get hard, actually cause leaks from the hard, brittle material cracking. So I like the Ford water pump seal material. And if you have that, what you do is you open a can, mix it up a little bit. I like to use sealing material of various ages. It gets thicker as it gets older. We use a new can here to show you can use a new can if you want to. And you paint every part of the case that's going to be sealing. And again, moderation in all things. There are some engines I've seen where the guy has gooped on so much RTV, which I hate using. Do not use RTV, room temperature vulcanization material. I don't like it at all. It's a mark of the turkey. Keep away from the bearing sealing areas or the bearing areas by at least of 1/8 of an inch. Don't let anything run into any bearing area. Okay, you can only, if you have to, you can just coat this one case half. Clean out any area of the case where there's oil on the sealing surface, like here we have the cam plug area. This is very important. Clean that out, make sure there's no oil there. And then put a decent dab of fairly thick sealer in there in the cam plug hole. Clean off any material that goops on any part of the case you don't want it to goop on. And pretend you're painting a Picasso. Well, no, pretend you're painting a Rembrandt, not a Picasso. Paint a Picasso, you get all over everything. Now, usually you can just do the one case half. I find it's a little better to appease the Porsche gods by doing both case halves rather than just one, simply because you have less of a chance of getting leaks in the case. I actually put a case together that had very nice machined surfaces. It was a really virgin low mileage engine without any sealer at all, just to see what would happen. And what happened was it didn't leak a drop of anything, because really most of the sealer would be forced out of the case. And when the sealer is forced out of the case, of course, it goes either to the inside or the outside. If it goes towards the inside, it goes towards the bearing holes. So be very careful when you put it like on the middle main area here. Don't get too near the bearing holes, and don't put it on too thick. There's even a case of one engine. It was gooped with so much RTV that the RTV clogged an oil passageway inside the crankshaft. And that resulted in, of course, the failure of the engine from too much sealing material. Now, if our camera can follow us a little bit, we'll go over and, like I say, I like to goop the other engine case half, and this is the main case half, left-hand side, that has the studs in it. It's already attached to our engine stand. We kind of did that while you were out having a beer or whatever. I like to paint this just lightly with the Ford water pump sealer, like so. Now back here on this piece you can goop it on a little thicker, but again, don't get too near the bearing surfaces. Pretend, like I say, that you're painting a masterpiece or painting by the numbers. And get your cam plug out, get your lower end gaskets set out. I'm going to show you in a second which gaskets we will need. Every engine post-1960 takes the small beveled washers that we discussed when we were taking the case apart. And the beveled washers contain within them in the case the O-ring seal. It's usually red. It's about a 1/4 inch outside diameter. And that O-ring seal is what does a lot of the oil seal protection around the case studs, where the studs actually protrude through the case. It's 6 main studs and, well, 5 main studs and a through bolt. Okay, so we've got this on fairly nicely now. Be sure to replace the top fairly tightly. Also need blue Loctite. We'll get to that in a second. Okay, so now we should get out from the gasket set, and there's a Rhines gasket set. It works okay, except despite the fact that it says it's for a 912 65 to 69, it doesn't have the proper oil seals for the 912, late 912 isolated mount cooler. So don't use the Rhines sets for that. Anyhow, get out the little plastic bag that contains all the little goodies. Open it, either with your finger, a knife, or a pair of scissors, or whatever, and take out the seven little red seals, O-ring seals. There's actually an 8th black one, but that black one's really for the dipstick, although it can be used in emergency for a case stud sealing area. All right, here we have seven little O-ring seals. You put them someplace where you just will not forget them, like on top of the gasket set. They can run away, and be very careful with them. And get out our newly CAD plated parts, just back from the platers. We need the through bolt. We need 6 acorn nuts. I like CAD 2. It's going to be a nicer than average engine. Pick out the best ones you have. And we need the special beveled washers. Now remember, I told you not to plate these beveled washers because they can crack and you can't find replacements for these easily. In the past I plated some. I have a few that have not cracked, and I use this on the one case nut that's visible when you see the engine in the car. The others were put on the rest of the case nuts. Okay. Now you have to get our crankshaft, put the crank in, of course, before we put the case together. And we take it off from our nice little attachment, which is the other flywheel we're using. Like so. It takes a few seconds to get it off here. We wipe it off, make sure everything is as clean as possible. Put a little bit of our secret sauce on the main bearing journal area. Take our flywheel main bearing, make sure the little notches, little cutouts here, are to the rear, actually the front of the engine, like so. Then we hold it by the number 2 and the number 4 connecting rod, like so. And we drop it down inside the case. Let it set gently. Next step is to get the dowel pins aligned. Now remember, we made a couple of marks on the front, and though you're not going to be able to see this too well, we could turn the engine stand around. Let's get this one on first. You find the dowel pin, there it is there, and you rotate it until you can feel it go down. And the whole crankshaft will bump down a little bit there as it rests on the dowel pin. You do the same thing on the main bearing. Helps if you grab it by the connecting rod, lift up a little bit, and rotate. Sometimes you'll have to lift this one up to get the flywheel main bearing in place. Rotate it around until it's sort of lined up, and then try and set it down on top. Now if you don't get the bearing on the dowel pin correctly, there we go, and you try and put the case on, you will have a seized bearing. Let's get this one. Yeah, it looks pretty good. A fairly good test is to try and move the crank back and forth while pushing down, and if it doesn't move back and forth, usually the bearing is not down on the dowel pin. Now they both appear to be down on the dowel pin. Crank rotates freely. Next step is to put the camshaft in. Our camshaft, we have just gotten the gear on here a while ago. We've already gooped up the bearing halves, so everything is fine there. We take the mark that we use to align, to put the gear on, where the extension of the slot goes to the bolt and to the zero, and there are two dots. We get a close-up of this, I'm not sure we can, but there are two dots right there on alternate gear teeth of the flywheel, of the crankshaft cam drive gear. And of course this zero will go in between the two marks there, and that's the proper mesh for everything. So we rotate the crank a little bit and try a position like this. Got to move the rods a little bit. And I'll turn the engine stand so maybe you can see this. Make sure that that mark on the circumference of the cam gear is in between the two dots, two marks on the alternate teeth of the drive gear. When it is, everything is fine. And it is now, so everything is fine. Our next step, and very important, don't forget this or you'll be sorry. This little bottle cap-like device is a cam plug. And it fits down in the back of the, well actually the front of where the cam fits. And it helps to put a little bit of mucilage on it, Ford water pump sealer. And we'll do that. Actually in this case the thicker the better, so reach down deep inside for the nice thick bottom eaters. Stick that in, push it down a bit, coat the top with the thick stuff. Don't overdo it. We're actually sneakily letting the solvent material or the sealer material dry a little bit as we're doing this. It gets a little stickier and makes for better seal. Now the fun begins. You try and balance the connecting rods with being well lubricated in a nicely machined crankshaft and rod. It's somewhat difficult to do. Pray for no earthquakes. Go over and get your other case half. Try not to touch the sealing surface area. Reach over, look down, play bombardier over Moscow on the studs through the stud holes. Get it on, push down, tap the case a bit, like so. Rotate the crank a little bit, not much, make sure it's not seizing. We now have the case down. Make sure that the cam plug is still intact. Make sure everything looks kosher, and it is. Then go back and get your 6, 7 O-rings and a little bit of your secret sauce. Bring them over here. Before you forget it, take your case through bolt. Take one of the black bevel washer. Put the bevel always towards the case. Snap it down. Take an O-ring. Put a little liquid secret sauce on it. And bring it down over the threads carefully without ripping it. Okay. Bring it down into the bevel of the washer. Take another O-ring, lubricate it, usually with the excess on your fingers. Stick the lower through bolt through the lower through bolt hole till it comes up. Put the O-ring seal on. Go and get now the remaining 5 O-ring seals. Put a little bit of secret sauce on them. Helps to do this so they can wiggle around and not get torn by the beveled washer as the case is torqued down. Stick them on the 5 remaining protruding studs of the case. Get them down as far as you can with your finger. Like so. This little plate for the dipstick shroud will remove. It should have been plated before. We have others. We'll take that off and replace it. Okay, now get out the remaining 6 bevel washers. Since all you see of the acorn nuts and bevel washer is that side, we're going to put the CAD plated one there. Make sure the bevel is towards the case each time. So we'll compress and imprison the O-ring seal, like so. Okay, now get out 6 of the best, well, if you have only 6, you have no choice, but I have a selection of various ones of these. The acorn nuts for the case, get out some blue Loctite, not red. Put a drop of blue Loctite on the acorn nut, like so. This does 2 things. One, it will allow you to have the bolt seal nicely, but still be, you can tighten it up again later on in case you have to. The blue Loctite allows retightening of the fasteners. It also holds it pretty well, so they won't come loose from vibration, etc. It also lubricates the threads and reduces the friction. And when it does that, it provides for more accurate torque when you're torquing things down. Select the best of the 6. Look at the threads or the hex of the nuts. Find the best one. Put that on where it's easily visible, the frontmost acorn nut. Put the worst one inside here where you don't see it. Put the next best one back at the back, actually the front. Right, fans. Don't drop them when you do this, though they're pretty rugged. And don't drop them down inside the case, or you can sometimes have a heck of a time fishing them back out again. Put a good one down here. You can see this if you're underneath the engine, like when you're doing an oil change, and it's psychologically uplifting to see a nice, shiny, plated fastener there than an ugly, rusty, greasy one. Push the bevel, the case through bolt up. This can be an ugly one, but really you should use the second best one that you have as far as sealing surface on the through bolt, because that's the hardest to seal. And if you have a leak here, you have to disassemble the engine just about entirely, take the cylinders off, etc., to get to these things. Take your 15mm socket and a special 17mm box end, which is designed by virtue of a grinder to fit over the 17mm hex nut of the through bolt. Tighten the through bolt down enough to where it'll wedge the wrench against one of the studs. Then go around and do a preliminary easy torquing. And I use the pattern 1, 2, 3, 4, 5, 6, which we'll be showing you here. After you get them down, not tight, just like that, hand tight, you then want to check and make sure the crankshaft still turns, which it does. If it doesn't turn, something is wrong. Probably the dowel pin is not aligned right on the bearing. Now I know the book says, or the Porsche book says, to now put the washers and nuts on the cam plug area. I really think the main purpose of that is to prevent you from forgetting to do so. And we'll do that now. I like to use the 14mm across the flat nuts, though you don't have to, because that's original. But nobody sees them, but the Porsche gods know about that sort of thing. And the special the larger outside diameter spring washer goes with these larger 14mm across the flat 8mm nuts. So we can put them on now. These are the nuts that hold the cam plug area together, like so. That takes a 14mm wrench, which we just happen to have here. I would tighten them down to where they're snug but not tight. We'll come back after you do all the torquing and tighten them down a little bit more. Now while you're doing this, inspect any part of the case for any defects that you might have missed. It's a little late for that now, but a defect caught now is an engine you won't have to rebuild afterwards. Look around, make sure that all the washers are down there, nothing unusual is happening. Get these case acorn, or the nuts holding the cam plug just snug, not overly tight, like so. Come back, get your torque wrench. Now the torque on all the acorn nuts on post-1960 engines, actually anything not an A, beyond an A series, BC 912, is 29 foot-pounds. So we'll start about 14 and a half. We'll go around once and torque everything to 14 and a half. Like so. I like this pattern. I alternate from side to side, front to back. We turn the engine a bit, it turns okay. We go up to 20 foot-pounds. Click, 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 click. 25 foot-pounds, you creep up on it. I don't like the guys that take it down to 29 foot-pounds all at once. It's a bit of a shock. It's like taking a cold shower. I'd much rather sneak up on the torque. After we reach 29 foot-pounds, which we're now at here, the final torque, we will torque it 3 times. Porsche guys like that number. Here's 29. Make sure the crank rotates, which it does. 29, 29, 29, and 29. Does it rotate? Yes, it does. Go back and do it again. Aha, it moved a little bit there, so we'll do it one more time after this. Sometimes when you torque the case down, there's a little bit of relaxation that occurs, lengthening of the studs, etc. That's why 3 times through is a very good thing to do, and we'll do that consistently throughout the entire engine. I found that the 3rd time is a charm, which we're now going through, and they won't change much at that point, and you'll have a successful overhaul and not one that requires premature maintenance at less than 100,000 miles. Now don't forget, guys, we do have in some cases 250,000 miles of stress built up on these parts, so other parts can and will fail occasionally, but in general they ought to go 100,000 miles. Okay, make sure that the crank will turn. Remove these clips that hold the cam followers. Rotate the engine to the normal position. Take out your special wrench by wiggling back and forth like yay, and see if the crankshaft turns freely. Now, one connecting rod here will lock up as you turn it, so lift it up and everything will turn freely. Move back and forth, check the end play, make sure it has some. It'll have a lot, we haven't started yet. And now, take a rag and go around and clean off all the mucilage that's leaked out from between the case halves. And the less that's leaked out, frankly, the better. That means you haven't overdone it. But go around and take all the mucilage out everywhere, even in the seal area, or the flywheel area, you don't normally see. This way, when you've done an overhaul and somebody else goes down and takes the part, they'll say, my God, this is a hell of a good job. Jeez. Take it on the bottom of the case, clean it all up. Now our next step will be to put the through bolts through, but before we do that, we will now make sure that the cam plug nuts are torqued down using our calibrated arm, because you won't be able to get a torque wrench in place at all, to between 15 and 18 foot-pounds. With the blue Loctite, you don't have to overdo it. In fact, if you overdo it, you may distort the case there and cause seizure of the engine. I've seen that happen once or twice. And there we have what is known as the lower end. Our next step will be putting the through bolts in place, and then, before we put the 3rd piece on, we'll check and adjust the flywheel end play and put the flywheel and seal in before the flywheel. And I'll show you the trick on how to put the 3rd piece on with the timing or the distributor drive gear in place, and then how to fill up the oil passages with oil so that when you fire your engine up, you get oil just about instantly. Okay, so now we've done a lower end assembly. This is really one of the most exciting parts of the engine, and the next few stages here are also equally critical. So let's take a break now, go out and have another beer, and we'll come back and put the through bolt, the minor perimeter bolts in, case perimeter bolts, and then after they're all in, then we can do the end play adjustment. Okay, now we're going to put the case perimeter bolts on. This is a 356, so a 356 engine takes special 14 millimeter across the flat, 8 millimeter nuts. And those nuts are very hard to find. You can't buy them new. You must get them off an early Porsche engine. They also take a special washer whose outside diameter is larger than the usual 8 millimeter washer. Net effect is these washers and these nuts are found only on early Porsche engines, and you have to find an early Porsche engine to get these nuts.
refrigerators on.
7 case perimeter bolts here and 1 long one that goes underneath the engine at the rearmost position. These are K-Row. I like K-Max better. K-Max is close to Climax, and of course that's very nice to have usually. But K-Row will do just fine for this application. I like to have all the bolt heads have the same manufacturer's stamp or logo on them. And as you can see, they're all K-Row here. What we'll do is we'll put these in. It's not terribly difficult to visualize how they go in, but you should put them in from the left-hand side, the left-hand case half, and put the nuts on the right-hand case half. So,
And just cut like that, so
it's still going. Put the bolt in from the left-hand side, like so. The long one goes underneath. You use actually the best 2 that you can find of your 8 for the ones that are easily visible, these 2 up front. So we will select the best 2. That looks like the better of those. Likewise, underneath the long bolt goes in the first position, and all the other normal size, normal length bolts go in from there on in. Total of 8 of them. Get them in, get your special washers and nuts. And note that the nut will have a little mark, the manufacturer's logo usually, and the type and strength of the nut on this side. Put that on the outside so that the smooth side is against the case, or the washer as the situation may be. In fact, do the same thing we did before. Select the best ones for those that are easily visible. And we'll go through here quickly. And that one there looks nice. And that one over there will look nice. We'll have our assistant get that. There we go. There's a nice one. Like so. Select also the best washers that you can and put them in the most easily visible spots, these 2 nuts to the rear of the engine. Like so. Now the rest don't make too much difference, but I still like to see the ones on the bottom look pretty nice, since they're in fact visible when you're underneath the engine changing the oil or whatever. And it gives you a psychologically uplifting feeling to see those nice nuts underneath your engine. Okay, now I'll put the last 4 on. And we torque the same type of pattern as we did for everything else. I like to alternate from the middle to the outside when we're torquing these things down. It doesn't really make much difference on the case perimeter nuts, but I think the Porsche gods see everything you do, so it's much better to do everything that makes them happy. Then they tend to make you happy too. We put these in. We get out our 14mm socket and a 14mm wrench, which we have here, and then tighten them down snugly, but not tight. We use a torque wrench on even these. These are generally torqued to between 15 and 18 foot-pounds. I find the best way of torquing them usually is to about 17 foot-pounds. You can go all the way to 18. 1 foot-pound in those conditions doesn't make too much difference. Now these particular nuts and bolts are all CAD 2 plated, the gold CAD as it were. The original color for all the nuts and bolts on this engine is silver, CAD 1. And for a Concours, I would be doing this in CAD 1. However, since it's my engine, I can do it any way I want to, and I find that when it looks pretty, or prettier, and the gold does tend to make it look prettier, that you can get either a higher price for it or more satisfaction. It looks a little bit different and nicer than the stock engines. And I find CAD 2 has its place. In fact, CAD 2 is stock on the 912 series engines. So you have your choice. Customer is always right. If you wanted CAD 1, no problem. We're happy to perform CAD 1 services for you. If you want CAD 2, no problem. We have those parts in stock. Okay, do it twice, the retorquing twice at 17 foot-pounds. We can go to the bottom now and torque the bottom. And once the perimeter bolts are in place, our next step will be to adjust the end plate. And for that, we of course have to have the flywheel and pressure plate back from the machine shop. So we can adjust the end play and then eventually put the seal in. And speaking of seals, the Rhines gasket kit that I showed you has a blue seal in it. They used to have black seals, and in fact the black seals were the better seals than the blue seal. However, now they're putting blue seals in. As you can see here, this is a blue or bluish green seal for the flywheel. I don't like these too much. In fact, I'll put in a silicone seal for the flywheel. I don't like flywheel leaks. I hate them, in fact. They're a pain to fix. You have to take the flywheel off. I'd much rather not have the leak to begin with. So we're going to not use this seal. The black seal is okay to use in the third piece, but you have silicone seals you can get for the third piece also. This is a soft iron gasket we'll be using for the flywheel when we finally torque it down. We'll use a used one to do the initial end play setting, and after the end play is finally correct, we'll put the new one on. The next step will be adjusting the flywheel, and we'll do that in a moment. Compress that for the first time. Okay, now we're going to adjust the end play. I like to adjust the end play after the main case housings are together, but before the third piece has been installed. That way nothing in the third piece can influence anything like the end play. Now to do that, if your old soft iron gasket is still in good shape, you can use it for the trial adjustments. If not, I suggest you buy a second new soft iron gasket, because the soft iron gasket is designed to be torqued down once and compressed, and that's it. The outer circumference of the soft iron gasket is an oil seal that seals the crankshaft and the flywheel and prevents oil from leaking out between them and getting all over your nice new clutch and making a mess of things. So this particular soft iron gasket is in good shape. You find the two holes that are closest to each other, and likewise rotate the crank until the two holes of it that are two dowel pins of it that are closest together are up on top, and put the gasket on like so. Get out your old flywheel adjustment shim, the one that was in the engine before. It's a good place to start. Clean it off really well like we've done. Stick it in. Take your flywheel. We have not yet had a chance to surface the flywheel. What we'll do though is set the end play, put the oil seal in, and take this over to the machine shop, have the flywheel surfaced and balanced, but we can at least set the end play now. Put flywheel on, pardon my head, like so. Get out the flywheel nut, old flywheel nut, as long as it's in good shape, and the old flywheel nut washer. Use that for the trial setting of the end play, because you don't want to use a new flywheel nut for that purpose quite yet. Put the flywheel nut in hand tight. Take out your flywheel lock if you have a factory engine stand head like this one is. Put the flywheel lock in position. Take out your trusty 36mm wrench with breaker bar and start to torque things down. Make sure the engine stand is locked down tight. Torque it down pretty good. Make sure that the flywheel still moves. Take off your flywheel lock, and then go and get your dial indicator. Okay, we take our dial indicator. I don't like using feeler gauges at all. I'd much rather use a dial indicator. It's much more accurate and believable and reproducible than using feeler gauges and a piece of shim stock or something, or a threaded rod through here, and feeler gauge is ridiculous. So with a dial indicator on the flywheel, you move the flywheel in, out and in, out and in, about 4 or 5 times, and you see how far the dial indicator is moving. And here we're at about 6, and we come down to almost but not quite 0. So the end play here is about 5.5 or 6 thousandths. The tolerance range on end play is between 4 and 7 thousandths. I like to shoot for 5.5 thousandths. 6 thousandths in this particular situation is very good. The original shim, about 75% of the time, works out to be okay. You can use it again, and the end play is proper. 25% of the time or so, you have to change it, go to a thicker or thinner shim, and that's where a nice selection of end play adjustment shims comes in handy. And of course, over the years, the Maestro has accumulated a few of these things, like a 6-inch stack. Since there's about 25 of these things per inch, That's about 250 shims, not counting the thick Super 90 shims, actually less the thick Super 90 shims. You need this if you're going to do serious Porsche work, because these shims are required from about 0.3, well, from about 0.8 millimeters up to about 1.1, or about 30 thousandths up to about 45, 46, 47 thousandths. That way you can adjust for almost any possible combination of flywheel, crankshaft, etc. Anyhow, we seem to have about the proper in play, so what we'll do now is take the flywheel nut off and put the special silicone seal. I don't like using the gasket, the seals that come in the gasket kit. I'd much rather use the silicone seals. These will prevent seal leaks in all but the rarest cases, and where it doesn't prevent the seal leak, there's something else wrong. But we'll install the seal, then tomorrow we'll show you how to take the flywheel in the machine shop and show you what we do when we surface the flywheel, clean it up, etc. Note how it looks now. It won't look that way when we get back done. So let us take the flywheel off, and I'll show you how to install the seal. Okay, now to install the oil seal, the first thing we have to do is take out our shim that we have determined is the right size. We want to clean it one final time. We want to clean the area of the case one final time. We can remove the washer. It's now, or the soft iron gasket. It's now served its purpose well. We clean everything off inside here, including the threads of the flywheel itself. We don't want that flywheel nut to stay tight, not come loose. And then we take a little bit of oil, not the secret sauce, but just plain oil, and put on the end plate adjustment shim. That way it'll get some lubrication before the oil pressure is established and won't cause any harm to anything inside. We then put that shim inside, rotate around a little bit, and get out our seal installer. This seal installer is nothing more than basically a flat plate through which a threaded rod fits that screws into the crankshaft. This is a VW part, available at local VW part supply houses, but it works for Porsches. In fact, it's the bona fide OEM seal installer. We get out our silicone seal. This is a silicone seal made by Goetze, G-O-E-T-Z-E, Goetze. It works much better than any other type of seal. I like to use these a lot. They're the only things that work, especially if the flywheel has been ground down on the sealing surface. Where the seal seals on the flywheel sealing surface, it can wear a groove. And where that groove is, you can sometimes get a leak. If you grind the flywheel down, the only thing that will work to seal again is a silicone seal. We take our friendly Ford water pump sealer, about the only good thing that Ford makes, put a nice thin coating of it. The operative word here is thin, on the inside of the sealing area. Take our seal with the seal installer and put a nice thin coat on the outside of the seal itself. And this will tend to prevent any type of oil leaks from oil that can work its way out between the case and the seal. Normally that doesn't happen, but there's been some situations. One engine I saw that I had to rebuild. The previous rebuilder was nice enough to take a ball peen hammer and ding this whole area over onto the seal. Why? Because the seal was leaking. He thought that would fix the seal leak. Of course it didn't. It made it almost impossible for anybody to get any seal to work at all again. But I managed to get it so it worked pretty well. We got to do a little bit of remachining there. Anyhow, you screw the seal installer into the crankshaft, get the seal kind of happily towards the hole that's eventually going to go into, get everything snug. Further you go into the crankshaft with the main threads of the seal installer, the better off you are. And you can crank it down a little bit here, then take your 36mm socket and proceed to torque it down until it's actually fairly tight. The nice thing about the seal installer is even if the steel goes in at a strange angle, or a slight angle, the seal installer will correct that and make it go in flat eventually. And pretty soon it will bottom out against the case. You get it pretty snug. Like so. And then simply loosen it. Like so. loosen it to where you can get it off with your fingers, and you have just installed the flywheel seal. Take this off, clean it off. There will be some mucilage from the Ford water pump sealer. So clean that off. And then clean the area around the case where the seal is. Get that mucilage off too. It's nice to have no evidence of any seal material. It really looks impressive then when people look at your engine, or people who know how engines are built look at your engine. Clean off the seal too. And now for the time being, we'll show you how to put the third piece on. We'll have to put the flywheel back on just so we can rotate the engine over to put the third piece on the way I want you to do it. So for the time being, we may as well put the old soft iron gasket on just to protect things. It won't really make much difference. But we'll put it on just for the time being. And then go over and do the third piece. Now bear with us now. You can take about a 5-minute canteen break. We're going to assemble the third piece of the case and put it on. It helps with the flywheel on when you do that. That's why we set the end play and would have torqued the flywheel down had the flywheel been ready. But we'll put the third piece on now. Make sure when you put the third piece bearing in, the number 4 main bearing, that you've of course checked all the dimensions, both the internal bore of the case and the bore of the bearing. Make sure you also done that with all the other bearings, etc. And the specs for that are in the new version of Secrets of the Inner Circle, or of course in the Maestros spec book. I won't go through them now because to give you numbers, long list of numbers, wouldn't serve any purpose here. They're in the books and already written down. No sense repeating them here. But you got to check out all the dimensions of all the bearings, the case bores, etc. And when you do an engine overhaul, because if you don't, no one else will, believe me. So you best get the books and know what's going on. Read them. The trick here is to put the bolt, the main bearing dowel pin holder bolt for the number 4 main bearing. It's actually got a little dowel pin at the end. Screw it in until the bolt just barely protrudes. Just barely protrudes into the bearing bore of the case. You can get a close-up of that there. You want to get it so it just barely protrudes. Okay. When it does that, you then take the bearing and you note there's a lead-in groove on most bearings that allows you to lead in through the dowel pin bolt to where the dowel pin hole is. So you put that bearing in such that it just will fit in, and when you tap the bearing in, the slop will slide through where the dowel pin hole is. And then you can tighten the bolt down after the bearing is seated in the third piece of the case. So you get about like yay. And it helps at that point to spray a little WD-40 around to lubricate things, as well as a little bit of oil. We don't need our secret sauce here, although you can use the secret sauce if you want to. But you put a little bit of oil on both the bearing and the case. You can do it on the inside too. Turn it over, like so. Get it nice and well lubricated. It tends to slide in that much easier, as it is with all things. Then, you already have your bearing installation device, which is the old bearing, the one you took out of the case before. You clean it up, if it isn't already fairly clean. And you're going to use it to put in the new bearing. You set it on top. Now, rather than a big sledgehammer, I like a smaller hammer, one that you can control a little more. You tap alternately, side to side, like so. Trying to get the bearing in as evenly as possible. Try not to hit the edge of the case here. And drive it down to where the bearing is just flush with the case. Don't want to drive it in too far or you'll miss that bearing bolt hole. Just get it so it's flush, which it is now. And if everything else is fine, if you've done it right, you can torque the bearing bolt down and it won't pinch the bearing. Now if you notice any great resistance when you're torquing this down, stop and take it out and find out what happened. You probably just missed a dowel pin hole. If you want to be certain, you can now remove the bolt and look down with a flashlight and make sure you see the hole. But having done this a number of times, I'm pretty sure everything will work fine now. and it seems to. Now if you want to be certain everything is fine, you can take the entire third piece, reverse it, and stick it on the crankshaft, like so. And it should fit on nice and easily, which it does, and rotate nice and smoothly. No distortion, no problem. All right, so we turn it over now. We get out our CAD-plated oil booster line. We get out also our two special little barrel-shaped washers. Actually, they're gaskets, red gaskets usually, with a hole in the middle and a hole at the end. We dip in our secret sauce the end of the booster line to lubricate things, stick the one end in one of the barrel-shaped washers, lubricate the other end, stick it in, and now comes the interesting part. There's a curve here on this booster line that has to curve around one of the oil holes here. So you put it in like so. Now the question is, which way do you rotate these little seals? Note there's an oil hole down there, so obviously the oil goes down there. That's actually below the oil pressure bypass line, so that goes in like yay. And this one, there's a blind flange down there. There is no hole, so obviously the hole goes up. In fact, the hole's in the main case half, where this fits up against. If you do this wrong, you won't get any oil pressure or any oil getting back to below the booster line to make the booster line work. The top of the third piece, the oil hole in the gasket's pointing towards the main case half, and the bottom is pointing down towards where the oil booster line is. So make sure you get that right, because you'll be sorry if it's wrong. Okay, then we take our nicely cleaned distributor drive, cleaned off a little bit more, get any crud that might be floating around on it off, dip it in our secret sauce, or put some secret sauce on it, lubricate everything, put it down through the distributor drive hole with a case. Now don't forget the washer. This washer is a unique washer to the distributor drive, and you must keep that with the distributor drive or you'll be sorry. Put it all the way down, make sure it turns freely, it should. And I'll show you how we then install the third piece here in a moment. Now we've done that, we have to turn to the engine. Now on the main case, we have these seals that are found in the lower end gasket kit. They fit hither, tither, and yon. This black one fits in yon. On later cases made after 1963 and a half or so, though they have a larger oil pickup tube that takes an O-ring seal found also in the lower end kit, this type of O-ring seal. Now that's a beveled area that's been machined in the case. We do not have that here, so we don't have to use the beveled seal. So what we do is we take our secret sauce and lube up the seals. We've already cleaned out the case very well, so there's no dirt or anything in or around it. You put the seals here, like so. This little seal is the right one is the one found in the Rhines gasket set. There are other gasket sets that have a smaller outside diameter seal of this type that won't fit in the later model cases unless you use a little bit of grease to hold it in. If you do use the grease, you have the smaller seal and do use the grease, it'll work okay. But the Rhines gasket kits have the right one of these. In fact, they have two of these, so you can save them for later engines. Now in the lower end gasket kit, you'll find three third piece gaskets. The question is which one to use. Well, by process of elimination, this particular one here has oil holes on different centers. There's no oil hole here at all. This is for a pre-57.5 engine, so we can't use it. The other two are very similar. Now a difference in them is the fact that over here on this side, this has a little seal area here around the pickup tube, and this one doesn't. Well, this one without the seal around the pickup tube is for those cases that have the O-ring seal. So the later case is made after 63, so we don't need it either. This is the right one for a 1957.5 to 1963 normal and super. It's got the two cutouts for the oil seals here, and the one cutout there for the oil pickup. Okay, so we'll put this aside. We need that one. Our next step is to paint both the main case halves and the third piece with our sealing material, the forward water pump sealer, like we did on the main case halves. And again, moderation is what is the key word here. We don't want to goop it on too thick and get it all over the inside and or the outside. We want to put it on evenly, covering both sides of the studs. Don't overdo it. The main seal, the paper gasket, actually does most of the sealing anyhow, not the sealing material, so you don't have to really overdo it. But if you do have a case that has scratches or marks in it, then of course it's a good idea to put the sealing material on. Again, I've tried building engines that don't have any mucilage here on the third piece, and they usually work fine as long as the case halves, the third piece and the main case halves, are in good shape. So you goop the, in moderation, goop the sealing material on. You cover all the various pieces on the inside of the third piece, and that provides very nice sealing all the way through. And then you also, if we can have this focus down here a little bit, you also goop the third piece too, if you want to be sure, because the gasket is in between, and it does help to put gasket the sealing material on both halves of the case. Carefully around the oil holes, but not inside them, and not too much anywhere. And don't use the RTV, use the Ford water pump sealer or the Carroll K, which is the stock Porsche sealing material available for 911s and can be used for 356s. If you do drop your little brush, then of course take a rag and wipe off any area inside that you've gotten the mucilage onto, like so. Carefully around the oil pickups and on every other part of the case that you can see. Okay, now we're ready. Now sometimes these gaskets, when you go to put them on the third piece, won't fit. They've been shrunk over many, many years of laying on the shelf. If that's the case, you can put the gasket in hot water, let it sit for about 10 or 15 minutes, and then it should expand enough to be right. Now see, here we have a little bit on the tight side, but we get everything arranged as parallel as possible and very carefully bring it over the studs. We can usually get it on without destroying anything. You have to be quite careful and only go a few turns, that is a few screw threads at a time to get it over without tearing it. Even if we do tear a little bit, it will compress back down again, and the sealing material will help us a lot. These gaskets are not, as you can probably see, the finest in the world, but it's what we have to deal with. Oh, we broke it here. All right, we'll go get another gasket. We fortunately have a few of these. If your gasket is a little bit too stiff, or when you go to put it on, it just doesn't fit right, try soaking it in hot water for a few minutes, and then you'll find it should fit pretty well. Like we just had a problem with one, so we're going to use another gasket that's already been soaked, and we find this one fits on really rather well. It goes over all the studs without breaking any part of the gasket. And it takes some time to do this. You just can't push it on one side at a time. You have to alternate carefully from stud to stud to get it down, like so. There, say hallelujah. All right, now you clean off the bearing area here, the number 4 main bearing, and you get out the secret sauce that you've been using. It helps to coat the gears. You can also put moly lube on the gears too. In fact, if you were storing this engine for any length of time, I'd put moly lube on the gears. We're going to be firing this up and using it fairly quickly after it's built, so we won't put moly lube right now. But you can put it on if you want. It also helps to have the flywheel on so you can turn the crankshaft over, exposing more new uncoated gear area to be coated and treated. Like so. Put it all over everything. And we're just about ready to put the third piece on. Now I'm going to show you a trick. I know the book says that to put the distributor drive in, you have to do it after the engine is completed. We've got it here inside the third piece. We're going to put it in now. And the way we do that is, I don't know if you can focus down there, Jeannie, way down inside is a slot. And that slot is actually a cord cut out of the distributor drive top. And it's got a narrow side and a wide side. And the narrow side should face towards the rear of the engine. If we get it like it does, facing towards the rear of the engine, and then rotate it just a tad, about 30 degrees, to where it's facing like so, then it's lined up properly to go on when we put the third piece on. Okay. Now, what we'll do is, we have to turn the crankshaft over to top dead center on number 1. We find top dead center on number 1 by taking our finger and putting on the intake cam follower of number 1 cylinder. And when, turn the engine over clockwise, and eventually you'll feel the intake cam follower rise and then fall back down again. After it falls down, it's then coming up on compression on number 1 cylinder. Keep turning until the rod comes out as far as possible, right there. That's top dead center on number 1 cylinder on compression. We let the engine set. At that point, we come back over. We get our third piece, and we carefully feed it over the studs, get it in, and tap. And by appropriate tapping, it should fit on. And then the slot should be parallel to this split here. The cord cut out in the distributor drive should be just about parallel to here. And though you can't see it, I can, and take my word for it, it really is parallel. Okay? Now, we get out our 11 special, smaller outside diameter washers, like so. They're not as a large outside diameter as these or these washers are. We put them on the third piece. Now, the third piece nuts, don't forget, are supposed to be 12 millimeter across the flat. Now, on this engine, when we first went to take it apart, they were, of course, 13 millimeter across the flat, and that told us that the engine had been overhauled before, and lo and behold, it had been overhauled, and by somebody who really didn't care very much. They put the wrong nuts on the third piece. These are all 12 millimeter across the flat nuts, and they're available these days. In fact, Jap cars use a lot of them. So what we will do is we'll pick the best one of these 12 with the best threads, etc., and we'll put it here, right where it's most visible, like so. We'll take the next best one, put it over here, which is also quite visible. The third best goes over here. We use this one here for that. The worst ones of your 11 can go in here because they're not seen. The pulley shroud covers them up. So I'll put the bad looking ones in there. This allows you to get rid of some bad ones you may have. If you have a good selection like the Maestro does, you can use good ones on everything. Even his bad ones aren't so bad. They're pretty good. Kind of like sex, you know, when it's good, it's great. And when it's bad, it's still pretty good. Anyhow, you put all 11 nuts on loosely, and you go back with a wrench or a socket, 12 millimeter across the flat. Oh, and when you're putting these on, make sure the little manufacturer's mark logo is on the outside. The Porsche guys like to see that on the outside, and they smile upon you when they do see that. So then get out a 12 millimeter wrench or socket and tighten everything down evenly. We'll use our favorite Sears socket for this. And it's best to start from the middle, like this. Don't really tighten them down a lot, just tighten them down to where they're snug. Make sure the crank will rotate okay as you do this. There is no area where it's binding. If it is binding, it indicates either the bearing was not installed right or you have a different third piece. If you go to put third pieces on that are different, it can be done, but you sometimes have to loosen everything and then tap in various directions here. Loosen all the bolts, tap on the third piece of the case while rotating the crank till you find a position where the crank rotates fairly freely. Now, since this is the same third piece that was on this engine originally, it's also indicated by dowel pins. There are two dowel pins inside that align the third piece that the main case has. And since they have not been changed, it should fit on and the crank should rotate okay and everything should be okay. Now, sometimes there are problems, but in general, 9 times out of 10, there aren't. In fact, the factory was so confident in the late 912 series that the third pieces would all interchange, they stopped putting the 3-piece match number on. Okay, so after you've gotten the nuts snug and the crank still rotates okay, take your torque wrench and torque these to about 17 foot-pounds. The book says 15 to 18. I like to use 17 as a good round number. And also do it alternately, kind of around in a circle, like so. So you tend to torque them evenly. And after you've been around once, it helps to go around in turn to make sure you didn't miss any. Because it is possible to miss some when you're doing them alternately like this. That we got. That we got. That we didn't get. The hardest one to get is the lower right-hand corner that we got at this time, but sometimes you can't get that. On earlier engines, that's a hard one because of the oil pump pickup casting. On late 912s, they changed that to where you can get to it easily, but it took them 15, 20 years to figure that out. Actually, on the very early 356As, you could get a wrench in there with no problem, but in the later ones, in the Bs and early Cs, you couldn't. Finally, some guy at the factory realized that was the case, must listen to the mechanics, some good engineer, and change the case design a little bit so you can get a socket in there. There's one we missed. It's off, we got it now. That's why it pays to go around in turn afterwards on the final torque. Rotate the engine, see how smoothly it rotates, no problem. You got the third piece on. Our next step will be putting the oil pump drive in and then putting the oil pressure relief and bypass valve plungers in. This is the bypass valve, that's pressure relief. And then putting on the pulley, etc. We'll take a slight break now as we get the parts. Okay, we have the third piece of the case on. Now don't forget, after you put the third piece on, you should go around the entire third piece and clean off any mucilage that has leaked out when you torqued it down. That's the mark of having done it right. Now, you've already gone over this once, so we'll just do a minor one here to show you what it's like so. Clean it all off very nicely. Now we're going to put the oil pump in, and following that the pulley shroud and then the pulley, and also the oil pressure relief bypass valve and plunger and spring, and oil pressure relief valve and spring. So we have here our oil pump, like so. We replaced the oil pump drive gear. Remember, it was worn pretty badly. And we've cleaned off all the gear teeth individually, one at a time, with a paper towel or rag, spraying WD-40 after having cleaned it in very good cleaner like Zep, etc. If you need to replace this O-ring seal, good luck. They're very hard to find, but you might try Stoddard Imported Cars in Willoughby, Ohio. They used to have them. This one was in good shape, so we treated it very gently. Okay, it's all set to go now. And there are two oil pump gaskets in the lower end. The smaller one is for the small pump, very simple to remember, and the bigger one is for the big pump, post-1960. The small pump is, of course, pre-1960 or 356A. This we don't need. This one we do. The oil pump gasket goes on like so, and it only goes on this particular way, where the holes cover the dowel pin holes that are in the cover to align the cover, and also go over all 4 bolt holes very nicely. Note this ring here, circular ring, around the oil pump with a area here, little groove. This is designed to capture any oil that might leak out through the pump, bring it around the circumferential ring and into the intake side of the pump, so it doesn't leak out through the pump. You do not use any mucilage on the pump. The main reason, if you put mucilage in here, it'll plug this ring, and therefore this ring won't do its job. So don't put any mucilage on the pump. Instead, just put the pump gasket on, the cover gasket on dry. In fact, what you should do is put this oil pump together in the third piece before you assemble the third piece and check the end play of the pump. Now we've already done that. That's okay. We don't want to show that here because we don't want to make this videotape 15 hours long and you wouldn't be able to afford it then. So you take our pump, you take our special sauce and goop the inside of the oil pump area with the special sauce. That will provide nice suction when the oil pump is first fired up, when it's first turned by the engine, when the engine is first fired up. Pour a little oil. Don't have to use secret sauce on everything. Pour a little oil on the gears. Get all over the gears nicely. And quickly stick the oil pump into the case and turn the flywheel over as you push gently until oil pump clicks into the cam drive like so. Then take the special long bolt I told you to put away somewhere so you wouldn't forget. 3 nuts, 6mm nuts, 10mm across the flat, and 4 washers. Get out the red Loctite if you want to be sure, and put a drop of red Loctite on both the stud and 3 nuts. 1, 2, 3. Put the cap on the Loctite again. Put a washer on the long bolt. Put the long bolt in. Screw it down. Put the other 3 washers on. 1, 2, and 3. And put the 3 remaining nuts on. Of course, leaving the manufacturer's stamp or logo on the outside, if at all possible. Now, the torque wrench you probably have probably does not go down to the 10 foot-pounds required for these 6mm nuts. And 10 foot-pounds is actually a little bit steep anyhow. So what we will do is use the old calibrated hand technique for this. And you first tighten the stud down, or the long bolt down, until it's just snug. It helps also to rotate the engine occasionally to make sure nothing is seizing. Every now and then, if you use a different drive gear in the oil pump, you can sometimes find it will actually interfere with the camshaft. And when you tighten down the oil pump drive nuts, that the oil pump drive will actually seize, and the engine will be very hard to turn over. In that case, you have no choice but to replace either the oil pump drive or the oil pump itself with another one. That happens very infrequently, though, and if you're putting back together your oil pump drive with no modification, then the odds are very high that that won't happen to you. Now, as a doctor in Texas who is a real perfectionist, as doctors should be, and what he does is he makes his own oil pump gaskets up. To set up the end play of the oil pump, which should be on the order of 3/1000 of an inch, he uses different gaskets. He makes his own gaskets from paper bags from the supermarket. He measures them and finds that paper bags vary in thickness from about 1/1000 of an inch up to about 4 or 5/1000 of an inch. And by getting a variety of paper bags, he can make gaskets up and adjust his end play on his oil pump to be where he wants it, about 2/1000 of an inch, and maintains about 50-55 psi oil pressure in his Porsche engine in his 66 VW bus. All right, look at that. It spins very nicely. The oil pump also drives a tach drive, as is doing now. And we've installed the oil pump in the case. Next step here is going to be to install the oil pressure relief and bypass plungers. We've already cleaned them up. We will also clean out the third piece of the case. The oil bypass is in the third piece, and the oil pressure relief is in the main case halves. Spray a bunch of WD-40 throughout everything. Make sure you're getting it all nice and clean. There are two special gaskets that fit over here. They're in the lower end gasket set, and we have them right here. These are copper rings that are compressed as you tighten the cap down. There's a seam in this copper ring, and the seam should go on the bottom. So you put the copper gasket on that way with the seam on the bottom, and that way you don't have much of a leak. Well, you don't have much of a chance of a leak. Use the better of the plungers for the oil pressure relief valve, and the poorer plunger for the bypass valve. This is less critical, though they both do play a role. So this one here, let's see, this one here is the better plunger, the one on the right. And this time you take a little bit of oil, pour it on the top of the plunger, and then stick it in. Oh, we have one more modification to make. You must make certain, when you do this, that the heavy-duty spring, that is to say, the one with the thicker wire, is used for the oil pressure relief valve, which is this one here. Thicker wire, fewer turns, but the thicker wire. And that goes in here like this. You screw it in with your fingers a few turns till it's in good. Take the other plunger. This is on the weaker spring, of course. This is the bypass valve. Put that up from the bottom. Like so. And screw it in. And take a big screwdriver and screw everything down. Clunk. Until it's fairly snug. Note that we've CAD plated only the caps in this case. In fact, the better cap should be used on the bypass valve because that's more easily seen. This cap is not seen very much once, in fact, the heater boxes are on. And we get out our trusty vice grips we used to loosen these before. Put a rag over the cap, tighten the vice grip down, tighten the cap, and get the cap so it's snug but don't lean on the wrench. The rag will of course prevent the vice grip from chewing into the cap too much. You can use a screwdriver, but I found that no matter how much you try to tighten these caps down with a screwdriver, they can loosen up. And they can cause a massive oil leak if they loosen up. So I still like to use a vice grip. I suppose an impact wrench could be used, but you need an awfully large blade to do that with. Okay, now the next step here, before we put the pulley, shroud and the pulley on, is to put the oil cooler on. And you'll note that the oil cooler stud holes, we get a close-up of the oil cooler stud hole area, previously were smaller in diameter for the 6mm stud cooler. We have drilled these out at the machine shop to be approximately 8.4 millimeters, so the 8mm stud cooler can be used. Now before we put the cooler on, so we now have the oil pump cover in place and the plungers in place, you want to get oil pressure to your engine very quickly. The thing to do is to take two remaining seals in the gasket set, which are the oil cooler seals. These are the same size, thickness, and height as the seals that seal the main passageways in the third piece. Then pour some oil down the passageways. That'll fill up the passageways in the engine, and when you fire the engine up, it'll already have oil in the passageways. And then you'll be surprised to see the oil pressure idiot light go off almost immediately, provided your oil pump is working, of course. Now if you don't do this and just fire the engine up without first putting the oil in the passageways to fill up the passageways, you can actually wait about 5-10 seconds before there's sufficient oil being pumped by the pump to fill all the passageways. Also, if you put oil on this side, it'll tend to prime the pump, the oil pump, And that'll mean that it'll take suction and provide pressure much faster than if you don't put the oil in. So let's go get the oil cooler now, and all the other necessary pieces to put on the pulley, and we'll be back here in a few seconds. Okay, we're going to put a new oil cooler, late model style. You can tell the late model style from the early from the fact there's no dimples on the side, and there's lots of the metal lattice between the blades. We've also drilled out the holes here in the case to accommodate the 8mm studs of the cooler. As you can see, it fits on rather well. Before you put on a new cooler, however, you must make certain to take out the plugs. They're here. If you don't, then you won't get any oil to your engine. So take out the plug, make sure it doesn't fall inside the engine. Don't do it over the engine like I just did. And then clean off any crud that might be on the area where the plugs were. This is actually pretty clean now. Put your seals in the cooler stand area. Take a little bit of secret sauce and put it on the cooler area where the cooler seals, and likewise on the seals in the case. Take a little bit of red Loctite and put that also on the cooler studs. Just a little bit. Put it on the stud in the case too, like so. And then I like to use 13mm across the flat nuts on the 8mm nuts of the cooler. And I double nut the stud in the case, simply because that way everything will stay intact and won't come loose. So you put the cooler gently down on top of everything and get out 2 small washers and the 13mm nuts. Put them on first, just loosely. And then get out a 6mm washer and one of the 6mm nuts. Put a little bit of Loctite on the 6mm nut. Always put the cap back on the Loctite. And put the washer on first, followed by the 6mm nut. Get out your 10mm wrench and tighten the 6mm nut down just a little bit until it prevents the cooler from rotating too much. You want to then tighten the 8mm nuts on the other side down evenly, about a turn or so at a time, so the cooler is tightened down evenly and smoothly onto the seals. If you tighten one nut all the way, the cooler may twist enough to where one seal may not seal too well, and you'll have an oil cooler seal leak, which, believe me, is no fun, because to fix it you have to pull the engine. All right, so do about a turn at a time, alternately on the 8mm nuts. You can check the gap as you go along, the gap between the cooler and the case, and try and maintain it as even as possible as you tighten things down. If you find that one side is getting too narrow a gap, tighten the other side down. Like about now, it would be time to switch and go over and tighten down the 6mm nut a little more, as you can see. Then go back and tighten down the 8mm nuts. Now don't over-tighten these nuts. You want to get them snug, but do not lean on them, because if you do, you can tend to crack the case. And believe me, second to a thrown rod or a flywheel coming loose, a cracked oil cooler stand area of the case is a real disaster. You have to disassemble the engine entirely and ship the case down to Competition Engineering in Altadena, California. They do the best oil cooler stand repair that I have personally ever seen. Nobody who I've ever seen do a case, an oil cooler stand repair, has done nearly as good a job as Competition Engineering. Tell Ray Litz that the Maestros sent you. Okay, get everything snug, and you've installed the cooler. Your oil passageways are filled with oil now. Keep putting oil until no more bubbles come up. Takes about 5-10 minutes to do that. We won't show it doing here because it just takes too much time. And you now have everything set in the oil system. Our next step is to put on the pulley, and before you put on the pulley, we have to put on the pulley shroud. So we get out our powder painted pulley shroud, a little better than the one we took off, and get out our special short 6mm bolts. Now, since there were previously long ones in here, which are the wrong ones, they should be short 6mm bolts. Perhaps the previous guy messed up the threads, and this particular one is kind of munged up. So we may have a problem here, but let's see what happens. Maybe the Porsche guys will be on our side. After all, we're trying to do it right. And they occasionally give you a break. So you get out a couple of new washers. 6mm washers are cheap. You can buy 100 of them for about $5 or so. And you need about 100 to do an engine. And you put some Loctite on the 6mm bolt. Screw it in partially. Take the other one. Always put the beveled edge out on the washer. It looks nicer that way. See if we can get this one in. Yeah, lo and behold, it seems to go in. Get out the wrench and torque things down slowly. These particular two bolts are in fact short bolts, like I was saying, and they're special. If you use long bolts, you can really mess up the threads here, which the previous rebuilder did. And if you strip them out, then the only choice is to bore everything out and helicoil it so you can put back a 6mm bolt of the right type. It looks like you might actually be lucky enough to have this work. It's a little tight there from the threads being munged up, but it looks like it's actually going to seat okay. This particular side was okay, fortuitously. And now the pulley shroud's installed. This pulley shroud is the right one for the large pump. There's a bend here in the shroud to clear the large pump. There are others that have funny little curlicues here. Those for early A type with the small pump. Only this type here will clear the large pump easily. If you use an early type that doesn't have this bend here, the pulley can actually hit it and wear through it. So be careful. Okay, now before we put the pulley on, we have to put the oil slinger and the seal in. And here's a seal. We're going to use a black seal in the gasket kit today to show you that the black seals are actually pretty good. The factory updated from the blue-green seals to the black ones, and they work fairly well. We'll put that in with a seal installer. And here's our oil slinger. The oil slinger is flat. It's not beveled. If it is beveled, somebody's beveled it, not the factory. Sometimes you can see the outline of the key. And if you do see the outline of the key, it's sometimes best to put that in. There's the outline of the key there. Put that in that side. Now this guy actually beveled it a bit, so we won't be able to use that technique. We'll put it in like so. It should go all the way to the back. You clean out the seal area, and you get out the special seal installer. The special seal installer needed to install the seal. This is a special seal installer needed to install the pulley seal. It's a Porsche tool only. It's not a VW tool. You can't find it in the VW parts list. It's got a recessed lip about 1/16 of an inch or so. We'll recess the seal into the third piece enough to make it seal properly. The best you can do with a flat piece of wood or something on this seal area is to just put it in flush. This actually indents the seal just a little bit. So we take our seal and just stick it on the seal installer like so. And we can just set it here for the time being. Get our forward water pump sealer and give a very thin, operative word is thin, coating on the inside of the sealing surface of the case to prevent any leaks on the OD of the seal. Take our seal installer and our forward water pump sealer and coat the OD of the seal evenly throughout its circumference, like so. And take and just feed the threads of the seal installer into the crankshaft till it's fairly snug. And take the nut and tighten things down. Actually, we probably have to tighten down this a little bit more. That's what that hex nut is there for in the first place. Get out your universal wrench. You just happen to have. Universal metric wrench, of course. Everything's metric here. Proceed to force the seal in. Now don't overdo it because you can break the third piece of the case. Get it nice and snug. Back it off. Then back out your seal installing tool. And then, once you're done, you can see that the seal will be recessed into the case about 1/16 of an inch. Take your rag and clean off all the excess seal material from the third piece, so you've done a nice job here. And note the recess. Crank the engine over to where the key way for the key is up vertical on the top. Take your key, that's nice and clean now. Stick the key into the keyway, and then sometimes it helps to have a hammer around in order to tap it in just slightly, and occasionally a screwdriver to guide how you tap it. Actually, you can turn the screwdriver this way to get it in a little easier. Okay. Get your newly CAD plated pulley out. Lubricate the inside and the sealing surface with the secret sauce. And stick the pulley over the key. It sometimes helps to tap it a bit with your hand. If that doesn't work, then a good old rubber hammer comes in handy. Tap it in, make sure the key doesn't move, it's not, to where it's kind of flush. Get out your pulley nut with a washer and put the pulley nut on, like that. And then you need your 30mm socket, which, as you recall, you used to take off the pulley, and it was set to take it off. Tighten it down. Put your flywheel lock in place to lock the flywheel, which is another reason why we have the flywheel on here. Sometimes requires a little bit of maneuvering of the flywheel to get the lock in the right place. There. And now don't over tighten the pulley nut, because if you ever want to get it off again, it can be a real chore. Tighten it down to where it's snug. And now we have our CAD plated pulley nut and washer all attached. The engine is now about halfway built. Next step is to put the cylinders and pistons on, add the fuel pump, the generator stand, and all the sheet metal. And we'll eventually tighten the newly surfaced flywheel back down here, next edition of this tape. So right now we're going to take a break, have a beer, and go get something to eat. Thank you for your attention. We've already adjusted the end plate, which you saw before. So the first thing to do is to get out a nice clean rag or paper towel, clean off the dowel pin area of the crankshaft, and likewise of the flywheel, which we've already done. Rotate the crankshaft until the two dowel pins that are closest together are up at the top. Makes life easier that way. Get out your soft iron gasket, the new one from the lower end gasket set. Cut it with a pair of cheap scissors. Not the gasket, but the plastic bag holding it. Take out the soft iron gasket. Find the two dowel pin holes that are closest together. Put the gasket on, like so. It's the only way it fits on when those two dowel pin holes that are closest together lined up. Get out your flywheel. This is our old flywheel that we have had machined, balanced, and doweled. So the pressure plate only goes on with a tolerance of about 1/10,000th of an inch. And when we balance the pressure plate, everything stays balanced. It's marked here. And the pressure plate has a mark on it likewise. You can align the two marks, and that way everything stays in balance. Okay, the other side of the seal has been polished on the sealing surface so that it allows the seal the best chance to seal. What we do now, take a little bit of oil, which we conveniently have here. Don't use the secret sauce with the STP, just use the oil. And oil the sealing area, the flywheel, like we're doing. Put it just a little bit on the shim area too. Try not to get it down inside the dowel pin holes. You don't want to have anything retard the sealing there. Take a little bit of the oil, put it on the flywheel seal. And the operative word here is a little. Don't overdo it. And don't get it on the gasket, etc. Then take your flywheel, find the two dowel pin holes that are closest together, usually sometimes marked with a 1 or a notch or a 0 or something on this side. Put it over. You're allowed to look. Get everything aligned. Wiggle it back and forth and push. And so on. Get out your flywheel nut. The good ones I like to use are the ones that are almost patriotic in the red, yellow, and blue box. The Maestro has the world supply of these things, so in case you need one, you can get them through him. This flywheel nut can be distinguished by having a dark hex head area. Some of the other flywheel nuts have a nice, bright, shiny one, and they tend to break at about 100 foot-pounds of torque or so. Note also that the threads end at the nicely radiused area before the rest of the nut begins. Some of the Brazilian nuts, the threads go all the way up to and into the radius, which makes it a hell of a stress riser, and they sometimes fail at very low torques. This flywheel nut with a blackened hex head is the only one I've seen that can take the Maestro's 425 foot-pounds, he likes to torque his nuts to, without failing. There's already needle bearing grease inside the needle bearing, so you don't have to put much more in. In fact, if you put too much more in, it'll come out on your clutch. So take the flywheel nut, put the washer on that you saved from the old flywheel nut. This is a VW washer anyhow, so in case yours is no good, you can use it. Set it on there. Get out your red Loctite. I like to use red Loctite. It helps. Makes it a little more difficult taking the nut off, but not that much more. Put just a drop or two around the threads. Again, moderation. Stick the flywheel nut into the flywheel. Screw it down as far as you can get it. Get out your flywheel lock if you have an engine stand that takes a flywheel lock. Put it in. Tighten it down. In fact, this time, since we're doing a pretty good torquing of the flywheel nut, we'll have to torque it down, torque the nut down, bolt down actually, quite nicely. We don't want it to come loose. There you go. You can also do this flywheel nut torquing on the ground if you take a long piece of angle iron, about 6 feet long, and put 2 bolts through the pressure plate bolts here, like these two, and that'll keep the engine tipping as you torque the flywheel nut down. Get out your 36mm wrench and torque it down to where everything is fairly snug. Like that. Now on this engine stand, this factory engine stand, you can't really torque the flywheel too effectively with the arms here. So we have to turn the engine over so it's upside down. But if we do that, the distributor drive gear that's inside the third piece here can fall out. So we're going to stick the distributor in temporarily to make sure it doesn't fall out. And while we're doing this, we also take our CAD-plated fitting that fits inside the case, the oil return line, and put it in. Note that it has 2 ends, one with the somewhat beveled side and one without, just flat and big. Beveled side is where the line attaches. This side goes in the case. So you put this side in the case. It's 11mm on the threads. So we get out our 11mm wrench. Which is here. and tighten it down to where it's pretty tight. But don't overdo it. We'd like to remove it again. Well, actually, we don't want to remove it again. Hopefully this engine will stay together now for 200,000 miles, or most of your coming lifetime. We torque it down pretty good. Now that's in. We can get out. We're going to use an 050 distributor, so we can show you how to install it. Note the cord cut out here. It fits in, of course, the appropriate cord in the distributor drive gear. And you put it down, wiggle and push, and it goes in like so. Before we put that in, however, we have to put our distributor bracket, which we had plated, in place. The bolt through the bracket takes a washer on both the bolt head side and the nut side. Now the 050s, occasionally, the body will hit the stud here. And to avoid that, what you can do is one of two things. Pull the stud out by putting two nuts on it, locking the top nut against the bottom and backing out the stud using the bottom nut. Either grind down or have the machine shop cut off part of the stud, don't need much, about 1/8 of an inch, or put a short bolt from a camshaft, say, in to replace the stud. And that'll allow clearance with the bottom of the 050 distributor. We put the drive on, or the clamp, the distributor clamp on, and it can go either of two ways. This way, which is wrong, or this way, which is right. We line things up with the tab, push down, twist the rotor until everything falls into place like that. And we tighten the nut down. It's a 10mm nut. You sometimes have to have 2 wrenches. Don't have to set the timing right now because we'll probably just pull up this distributor afterwards to allow access to the lines. But when I turn the engine over, this will then prevent the distributor drive from falling on the floor and making its reinstallation a requirement. Get out. We can torque the clamp down properly. So we'll put a 12mm or a 13. Actually, originally they used 14 on the third piece there. But 14mm nuts are at premium right now, and you may just want to use a 13. It's very hard to tell. Pull the distributor up a little bit, put the nut on like so. We'll have to use an open-end wrench to get in there usually, and tighten down the nut as you hold the distributor in place. Show you how to adjust the timing here later on. And that'll hold everything in place for the time being while we torque everything down, i.e. the flywheel nut. Now, rotate the stand around, pull up the holding device, rotate it 180 degrees, put the device in. You sometimes have to use a little friendly persuasion on the like so. And we're almost all set to go. Why don't you call Mary? Okay. Now we're ready to torque the flywheel nut. So in fact, what we need is a torque wrench. And here we have the Maestros B52 electric torque wrench, which is a 0 to 600 foot-pound torque wrench, calibrated like so. Electric, as a little light comes on when the proper torque is reached. And this is really the right wrench that you should have, though very few people do. You can also use the calibrated body technique, whereby if you weigh 150 pounds, even if you stand 3 feet away, and the flywheel nut, when you're parallel to the ground, parallel to the horizontal, that's 450 foot-pounds. I set the torque on this to 425 foot-pounds. That's what I like to torque my nuts to. And now we have to call for a groupie from the audience. Okay, groupies, let's see, you over there. Okay, come on over.
Oh,
you look good.
Pick me!
All right, you're picked. Come on. Assume the position.
Oh, gladly.
She stands on the stand so it doesn't tip over. And now we put the wrench on the flywheel nut. Torque it down a little bit. Has a ways to go. Like so. And now, if we've done this all right, the light should come on.
There it's on.
And we reached 425 foot-pounds. That's all we need to do. We can now put this torque wrench to bed for another day. And we thank you, groupie. What number are you?
I'm number 10.
Number 10, okay.
Thank you, Maestro.
All right, we'll now proceed from this to the cylinders and pistons. While we're here, we can put the plug in, oil drain plug. That's simply a 19 millimeter across the flat plug. We'll take a break at this point and shift the engine stand around, reset everything. Be back in a minute. Okay, now we're going to put the cylinders and pistons on. And this is the Japanese big bore kit, the NPR or Nippon piston ring big bore kit. I do like these. They've been bad-mouthed by many people, but mainly because of the way the standard overhaul on an engine is done. Standard overhaul of an engine consists of fly cutting the cylinder heads using the big bore kit and slapping it all together. When you do that, the big bore kit is designed to have about 9.3 to 1 compression. When you fly cut the head, you actually raise the compression to about 9.5 or above. In fact, on these normal and super engines with small heads, about 58 cc's or so, you can get almost 10 to 1 compression. And with the gas we have these days, the pistons will fail with the ring land area between the rings breaking. And when that happens, when the first ring land breaks, it starts to smoke, and when the second ring land breaks, there's a direct passageway open up from the oil holes here to the combustion chamber, and gases will bypass past here and torch this area and melt the piston. So you want to keep the compression reasonable. The main reason for these failures is, of course, knocking caused by the poor quality gasoline we have in the U.S. today. So what I have is a computer program that calculates the compression ratio based on the head volume, the piston cylinder type used, and the number of shims used, and selects how many shims we have to maintain the compression ratio between about 8.6 and 8.9 to 1. You go much above 9 to 1 these days, and you will have piston problems within about 20 or 30,000 miles. The net effect is the program they ran through, which is a very simple program that the basis of which is described in the Secrets of the Inner Circle under the Calculating Compression Ratio section, determined that I have to use the 1 millimeter thick copper base gasket plus the one thin copper base gasket that comes in the top end gasket set. And we have both of those here. These are the 1 millimeter thick copper base gaskets that the Maestro has a good supply of. And these here are the thin 0.25 millimeter copper base gaskets that come in the top end gasket set. We'll put one of each on to lower the compression to a calculated 8.85 to 1, which is a decent compression ratio, give you enough power and everything, but will not cause premature failure. One more thing I should mention, well, two things actually. One, every Porsche piston will have an arrow pointing towards, well, that side, say. This arrow should always point towards the flywheel. In every case, and no matter how the pistons are arranged, this arrow should point towards the flywheel. Secondly, the big bore kits have either a yellow dot or a black dot on them. Refers to size, etc. So try and keep all the different pistons together, make sure they all have the same type of dot. Within a given set, the information that comes in the big bore kit says you can interchange any piston within any cylinder in the kit, but I try and keep the pistons and cylinders together. Now, I balance these pistons to within 1/10 of a gram. You can balance them by removing mass off of the inside skirt area here, but I buy pistons in quantity, piston cylinder sets in quantity, take the pistons out, weigh them all, and by the law of large numbers, if you have a large number of sets, you can get pretty much them all balanced by rearranging the pistons and cylinders. And of course, the piston and cylinder goes together when you move them around, and get pretty much 9 balanced sets out of 10 sets, say, all balanced within 1/10 of a gram. If they're not, then you can remove a little bit of mass around the inside here and get them balanced very nicely. They normally come balanced within 2 or 3 grams. I've never seen a big bore kit out more than 5. I've seen stock sets out 15 grams or more. We recently had a Molly set that was out 23 grams and could not be balanced. Okay, so what you do is you decide which side you're going to put on where, so you can arrange the wrist pins and everything, and then get out a piston, get out the snap rings, retaining rings for the pistons. Come in a little plastic bag like this. Open the plastic bag, take out snap rings, lay them out someplace. Take out a piston, decide which side it's going to go on. This piston is going to be number 1, this number 2, 3, and 4. Number 1 goes on with a wrist pin going out that way, going in like so. So we push it out that way. Take our wrist pin retainer and installation device, which is merely a pair of pliers. Now the wrist pin retainer has a smooth beveled side and a sharp edge bevel side. The sharp edge should go towards the outside, making it all the more harder for the wrist pin retainer to snap out of its groove. So we always put them in that way. That's one of the little tricks you won't find in any book except the Maestros book. You squeeze it very gently here with a pair of pliers, just so it fits in. Get it so it's in the groove. There's a little groove inside there. You can use the edge, snap, and rotate the circlip to where it's down at the bottom. You're done with that one. Go to the next one. Arrange the arrow to point towards the flywheel. This is number 2. The wrist pin goes in from this side. Usually you can push these out with your finger. Occasionally you'll have to use the wrist pin removing device to get them out far enough. And again, check which side of the retainer is the sharp side and put it in like so. Now we won't bore you with all 4 of these, so we'll take a slight break here. While we put all 4, you can actually push the wrist pin back and use it to center the wrist pin retainer in the groove like so, and then rotate the wrist pin retainer to where it's down at the bottom, and we have completed the second one. We'll take a slight break and put all the wrist pin retainers in, the other 2, and then I'll show you how to clean them. We've got the all 4 retainers, 1 per piston in each piston. Now we're going to clean the cylinders. Now you might think those cylinders are pretty clean. You take your WD-40 can, spray in some WD-40, get out your nice cleaning device, a rag or paper towel, make sure it's clean, and take and wipe out the inside of the cylinder. Marvel at the amount of dirt that one finds on this nicely looking cylinder. Take the WD-40 and do it again. Take the other side of the rag or paper towel, another clean side of it, wipe it out, and marvel again at the amount of crud. Take a new clean rag or paper towel. You're going to go through a lot of rags and paper towels. You want to do a good job. And the third time is usually the charm. You can usually not get much crud out of here the third time. It should be fairly clean, and it is. So 3 times through on the cylinders, and do all 4 because all 4 are dirty. They have machining dust, etc. They have dust from the factory where they were made. It may be authentic, original Japanese dust, but it's dust nonetheless. You take and do it twice, and then you do it a 3rd time to be sure. And look at how dirty the paper comes out. That kind of dirt would remain in your engine to wear your rings, etc. I find it's better that you get it out, that you don't leave it in there. All right, now things are clean. We get out 1 of each of the shims, 1 thick shim, 1 thin shim. I find it better to have first thin shim installed, and the shim is not, the cutouts on the shim for the studs are not symmetrical. So you have to look down the cylinder and make sure that when you put the shim on, that the cutouts go where the cutouts in the cylinders are. And take your thick shim, it's of course got a beveled area and a non-beveled area. Put the beveled area on top. Again, you got to arrange it so that its cutout match the cutouts in the cylinders. Put it on like so. Keep the cylinder and piston together. Do the same thing with the other one. We'll show how to put one side of cylinders and pistons on and let you use your imagination for the other side, or this videotape is going to be 15 hours long. And nobody but the Hunt brothers could afford it. In fact, they probably can't afford it now since they're going to be broke pretty soon. All right. Now, get out the secret sauce. Cut it with a little more oil. And I'll put the secret sauce on the cylinder, but we use just straight oil on the piston once the piston's installed. That seemed to be the happy medium I found through use that works out better that way. So coat the cylinder fairly liberally with the diluted secret sauce, and then we'll show you how to put the pistons on. So that will be the next step. Okay. like to start on number 3 piston, do it first, get it out of the way. Clean off the wrist pin area of the connecting rod. Take a dab of your secret sauce, put it in the wrist pin area of the connecting rod. Now I have a factory engine stand head that prevents the wrist pin from going in this way. I have to put it in the other way. So that's what I'll do. You align the wrist pin with the bushing in the connecting rod, push, get it all the way flush, make sure the arrow is pointing towards the flywheel. Get out another one of the retainers. Make sure the beveled, sharp beveled edge is on the outside. Take your special installation device for the wrist pin retainers. Squeeze gently. Fits in. You can use the edge of this thing to pry it into the wrist pin groove in the piston, like so. Arrange the tabs of the wrist pin retaining ring to be closest to the crankshaft. Now, take and arrange the rings. The gap on the rings, this is the oil control 3 top compression rings. Oil control ring gap should be on the top, and everything else should be 90 degrees away from that. The way I found that works best is the lowest compression ring, third one in, the gap should be down, vertically downwards towards the ground. And then the other 2 gaps can be arranged at either here or here. But I found it's best to put the gap of the middle compression ring towards the exhaust valve. That's to help it run cooler. And the gap of the top ring towards the intake valve. Arrange them like that. And take some WD-40 and blow off the piston. You want to clean the piston too. In fact, we've cleaned these beforehand, so that's what you should do too. And make sure you don't have any dirty fingerprints or smudges, etc. on the piston. And get out some oil and just pour some oil over the piston. Now some people like to put pistons and cylinders together dry. I'm not one of those type of people. I'd rather lubricate the piston. Some people claim it allows for bad break-in. I find it improves the break-in. Even when machinists are machining a part, they have lubricant flowing in and around and over the part, keep it both cool and keep it from overheating, etc. And I'm in favor of that very thing. So I like to see you lubricate the piston very nicely. Don't move the rings when you do that. Then get out a ring compressor. I find the best ring compressor is this type, the band and pliers type. These are available from part stores for about $10 or so. Before you do anything, you clean off the ring compressor and then lubricate it. You can use the secret sauce for lubricant, or you can use just plain oil. Helps with the slide around the rings then. Slide it over the piston like that. Get out the pliers. Put it in the grooves of the band. Tighten it down. Make sure you get all 3 compression rings in that band. Now some of these pliers tend to snap loose too. And you have to be very careful with it. And here's where dexterity plays a role. You get the cylinder. Note the cutout, the flat part of the cylinder, doesn't have as many fins as this side. That always goes towards the middle of the engine. Put it on wrong, you won't get the other cylinder on. Slide it carefully over the studs. Grab a hold of your wrist pin or your snap ring compressor, piston ring compressor. With your knee to support everything, give it a little love tap with your hand. Being careful because you want to not hit the oil control ring too terribly hard. This band is not big enough to compress everything at the same time. Compress the band again. Now make sure the gap of the oil control is also underneath the ring compressor. So that the halves of the ring come together underneath the ring compressor. Tap with your hand. Voila. Remove the pair of pliers. Rotate the band so it goes around the stud. Rotate it around, bring it up. Put that aside. Hold the flywheel from turning and tap this down over the studs. Now, earlier big bore kits about a year or 2 ago had a problem where one of these studs was not machined right, and you couldn't get the cylinder over the studs. Since that time, things have improved. If you ever get one where the cylinder won't go over the studs, just take a drill and drill out the hole a little bigger. they have a gang drill that drills 4 holes at the same time, and one was set up at an angle and screwed things up. Push the cylinder in all the way, and now go over and do the number 1 side piston. We won't necessarily bore you with all that, but we'll put all 4 cylinders on. So if you want to pause for a moment, go out and get something. We'll be back in a second. To put the piston on the number 1 side, you just take the lovely secret sauce, put a dab on the wrist pin, grab your piston, lubricate the piston with the secret sauce too, and the wrist pin. Make sure it slides back and forth. Now on original pistons, you sometimes have to heat up the piston to get the wrist pin in. Big bore kits don't seem to need that. They slide in pretty easily. Make sure on the snap ring, make sure that the edge of the snap ring is a sharp unbeveled side. That goes towards the outside. Put it in with your special snap ring pliers. You can pry it in, push it in like so. Rotate snap ring so it's towards the center of the engine. Make sure the arrow points towards the flywheel. Take the rings and arrange them such that the gap of the oil control is on the top, the gap of the lowest compression ring is on the bottom, the gap of the middle compression ring is towards the exhaust valve, which is the outer extremities, and the gap of the top compression ring is towards the intake valve. And then get out the oil, coat the piston with oil. I like to do this, some people don't, as I was saying. I think it leads to much better break-in when things are lubricated. In fact, one of my recommendations on break-in is that you take 2-stroke motorcycle oil and put it in the gas at a ratio of about 1 pint or half a quart per 10-gallon fill-up. And of course, be sure to put it in the gas at the gas station. Just don't dump it in or you'll follow your spark plugs. And then put the gas in so it mixes the oil. Take your ring compressor, put it over the top compression rings, tighten it down a bit. These things are a little touchy. They can snap back at you, fall off on the floor. Take the cylinder, it's been lubricated with the secret sauce, put the cutout towards the middle of the engine, feed it gently. Now I have to come around here. And now I show you where dexterity plays yet another role. Tighten the compressor down a bit. Tap the cylinder. Stop before you hit the oil control ring. Move the ring compressor down to the oil control ring. Tighten. Hit the cylinder. Take off the band and strap. Now you'll have to go over and clean the other 2 cylinders before you put them on, and we won't bore you with that. But you crank the engine over now to where the other rods come out, and we'll put them on. We crank the engine over 180 degrees till the connecting rod on number 2 and number 4 is out all the way. Take a dab of secret sauce on the wrist pin bushing. Put a dab of secret sauce on the wrist pin itself. Already got the retainer in. Make sure it moves back and forth. Make sure the arrow points to the flywheel. Take piston, feed the wrist pin to the connecting rod bushing. Push inside. Get one of the 2 remaining wrist pin clips. Again, make sure that the bevel, the sharp edge is to the rear, well, to the outside. Put it in, push it in, arranged the snap ring edges so they're towards the center of the engine. Get out your last remaining piston, lubricate it, lubricate the wrist pin. We'll rotate the engine stand here so you can see a little more of this. Lubricate the wrist pin bushing. Take the piston, make sure the arrow points towards the flywheel. Stick it in. Push the piston pin in. The wrist pin, take your last retainer, sharp edge out. Put it in, push it in, Rotate it around and make sure it's in the groove. Put the ears on toward the center of the engine. Take some paper towels, clean our rag, clean off the piston. Arrange the rings, oil control on the top, lowest compression ring gap on the bottom, middle compression ring gap towards the exhaust valve, top compression ring gap towards the intake valve. Do that on the other side while you're here. This, I think, is the best arrangement of rings. There are others, but I find this to work fairly effectively.